After understanding how sequencing works, the next question is, what can we do with the data we obtain? One of the typical applications is constructing the genome of novel species. Here's a typical step-by-step for making a de novo genome. We focus on how to build a genome using sequencing risk, assuming that all adapters have already been removed, and each base in the risk is of high quality. Imagine we have several sequencing grids, each presenting a small part of the genome. The key idea in the genome assembly is to identify overlapping regions between these grids. By finding and marking this overlap, we can gradually piece together longer stretches of the genome. With just a few rich and very short genomes, this process can be straightforward and done manually. However, for large and complex genomes like the human genome, this task becomes extremely challenging. For example, there is a repeat region in the genome. The length of the subgrid cannot cover repeat region fully. As a result, the wrap of the genome is terrible, while the long grid can cover the region fully, helping to make a better genome assembly. That's why specialized algorithms and computational tools are required to automate the identification and marking of overlapping regions. This will be more detailed in BIOINFO101. It's important to note that the assembly of a genome from subgrids is not always straightforward. Sometimes we can only reconstruct a large piece of a genome called context or scaffold rather than a complete continuously sequence for each chromosome. This is especially true in regions with high complexity and repetitive sequence, which are common in both bacteria and eukaryote genome. As a result, the final product is often referred as a wrap genome rather than complete genome.